The real world is uncertain, and a good model must be honest about that. The mathematics of uncertainty is probability. It gives us a precise way to reason about chance, evidence, and belief. And it starts with ideas so simple a child understands them: a coin, a die, a card. Probability is just a number between 0 and 1. 0 means impossible, 1 means certain, 1/2 means an even chance. For a fair coin, the probability of heads is 1/2. For a fair die, the probability of rolling a 3 is 1 in 6. It is the fraction of outcomes we count as success. Two simple rules take us far. For outcomes that cannot both happen, the probability of one or the other is the sum. The chance of rolling a 1 or a 2 is 1/6 plus 1/6. And for independent events, the probability of both happening is the product. Two coins both landing heads, 1/2 times 1/2, 1/4. That word, independent, matters enormously. Two events are independent when one tells you nothing about the other. Two separate coin flips, independent. But rain today and rain tomorrow, not independent, knowing one shifts the odds of the other. Much of machine learning is about spotting when things are and are not related. Which brings us to conditional probability. The probability of A given that B has happened. Knowing new information updates the odds. The probability that a card is a king is small, but given that you already know it is a face card, the probability of a king jumps way up. Evidence changes belief, that is the essence of learning from data. This is the language models speak. A classifier does not output a hard label, it outputs the probability of each class. A language model outputs the conditional probability of the next word, given all the words before. Everywhere a model expresses confidence or weighs evidence, it is doing probability. So, the foundations of probability. A number from 0 to 1 measuring chance. Add probabilities for or multiply them for independent ends. And conditional probability updates belief as evidence arrives. Next, we move from single events to whole patterns of outcomes, distributions, and the famous bell curve. Chapter 19.